All right. So we're going to look at using Draft, and in order to do that, not only do we need Draft, but we need a Kubernetes environment, and we probably want the Helm tools as well, even though Draft actually can sort of take care of most of that for us. The quickest way to get a Kubernetes environment on a local machine is to use a tool like Minikube. Now, it turns out I've already got a Minikube environment up and running. So if I were to look at Minikube status, I see that I have a Minikube cluster up and running and it's configured, and I have a VM at a specific address. The instructions for getting Minikube set up are not something that we're going to go over in this particular class. They're well documented online as well as some of our other classes. But suffice to say, you need to get Minikube installed. In addition to that, you want Helm installed. And you can do that by downloading the Helm tool. Again, just go to helm.shell. Actually, we can pop over here. Helm.shell. Not Helm, sorry. Yeah, sorry, right, Helm. So, gee, it looks a lot like Draft, and that's why I got a little confused there. Helm's another tool that we use to talk to Kubernetes, and we'll talk a little bit about Helm charts, which is the language of Helm, as a part of looking at this Draft tool. But the real reason that we want Draft is that Draft simplifies the process of taking an application. Maybe we've written something in Ruby or Python or Go or Node or what have you, and launching it into a Kubernetes environment. Now, there's probably still some work that has to be done on the back end, some effort that goes into that, but most of it is covered by Draft, and we'll look at how we do that. So we would get Helm and it's always a good idea to upgrade the environment just to make sure that something hasn't changed too dramatically. So here it just says, yep, everything's still fine and upgraded. So we have Minikube, we have Helm, and then we want Draft. And Draft, same thing. It's an application that you install, Go application. The first thing you want to do with Draft is to do a draft init. It should say, yeah, everything's already there. Again, I've installed this previously. But basically what this has now done is Draft has installed a set of components, a set of packages that let us create default Kubernetes targeted environments leveraging the Helm backend engine and specifically the Helm tiller application within the Kubernetes cluster. The Helm init process actually initialized the tiller engine in Kubernetes. The draft init initialized the draft plugins, and now what we really need is an application. Well, luckily I have one. Just see, I'm in my draft class directory here, so did a pwd to get that. ls for the directory listing. We see we have nothing, so we're going to use the git application, git clone https. That's the process that we're going to talk to GitHub with, github.com. We have in rstarmer, we have a Ruby underscore hello world app. So it's Ruby underscore HW. We're just going to clone this here locally. Now, what we've done is we've created a directory called Ruby HW. Let me clear this up. Okay, so we have a Ruby HW directory. CD into Ruby HW. And we see we have an application. Now, this is a Ruby 2.5 based application. So if you haven't worked with Ruby before, it's still something to potentially consider. This is an application that I built to run, and it's really lightweight. We can actually look at the app real quick just to see what we're talking about here. In this case, it's a hello world.rb app. It uses Sinatra, which is a modeling language within Ruby. Lets you model routes and things like that. And here we see we have two routes, a default with a name world and a path that includes a parameterization. So in this case, there's an index or a parameter for name. It gets passed as a parameter into the index. If I don't do anything else, then the parameter still exists, name, but it's static, and it gets passed to index. And just for completeness, we can go look at the view, which is this index, this ERB template index. In our views, we have index.erb. And beyond all the boilerplate, deep down in the bowels here, here we see we have basically, we're going to say, let's go ahead and paste hello, and then this is a parameter here, name hello world. is the default, or whatever name I pass on the URL that I request. The rest of this is based on the Java Bootstrap, so there's a nice view of the image, but that's really about what we have. All right, so we have an application. Now the next process in all of this is to use Draft to actually create the boilerplate around our application. And we can do Draft create for that. And I'm also going to pass in the fact that I know that this is a Ruby application. Now, Draft actually has some logic to try to figure that out for us. Actually, we can do this without first. We'll just say Draft create. And the system first thinks, oh, this might be an SVG, but I don't have a pack for SVG. I don't know what it was thinking in terms of it being an SVG application. There was something in it that it liked. But then it found HTML ERB, and it said, oh, well, I don't have a pack for that either. And then finally it found Ruby, and it said, even though it wasn't super successful in determining that this was a Ruby app, that's what I'm assuming that this is, and that's what I'm going to use. The other way to do that, let's clean up what that created. So this created two, or actually three major things. We created a Docker file here. We created a charts directory. And we created a configuration file called draft.toml. TOML is another markup language or description language. The Draft community or the Draft developers felt that this was an easier language even than the YAML, which is a whitespace language. This one doesn't have whitespace issues, so I actually can see some potential value there. Anyway, so we're going to remove these things so that we can run Draft again and tell it specifically what we think it should be. So we're going to remove our Docker file, actually rm-rf, so recursive enforce. Let's get rid of our Docker file. Let's get rid of the charts directory. Let's get rid of that draft file as well. All right. So now we're back to about where we were when we started. And now we're going to run Draft again, but this time we're going to run it and tell it exactly what it should see, so it's not even going to have to guess. So that makes it even easier. So draft create -- pack equals Ruby. And it's just going to say, yeah, great, you told me it was Ruby. I'm not even going to try to guess. And here we go. I've done what I think is the right thing for you. So let's see what it actually created. So we did an ls to get the directory. And the first thing we're going to do is look at our Docker file. So let's go do more on the Docker file. And here we see, okay, we're going to start with Ruby as our application environment. We're going to use environment variable, or we're going to create an environment variable rather with the default port of 3000. So this is something you could override, but this is just an assumption that we're going to probably be using port 3000 for this. We're going to expose port 3000, so that's how we tell the container to actually let 3000 through effectively. And then we're going to run a couple of Ruby specific commands. One is we're going to run the bundle config app that will take our gem file and create a local set of libraries so that we have the proper libraries for our application to run. We're going to set our working directory to user source app. This is just where we want to run all of our applications from. We're going to make sure that our gem file has been copied over, and then we're going to install all those bundled application components. And then lastly, we're going to copy in our application. Now, I notice one thing that's a little different here. This says Ruby, I expect to be able to run the app as app.rb. Well, that's great, but my app is called hw.rb, so as we can see up here in our listing. So we have a choice. Either we modify the Docker file or we modify our app. I think I'm going to modify the app just to make things consistent with, I guess, the way most people probably would have been writing their Ruby applications. I don't know why I called mine hello world.rb, but hey, that's just the way I did it. So we're going to do an mv hw.rb to app.rb. Great. So now we have an application running. We have the application ready to go. Now the other thing that we want to look at is the chart. Now this is based on the Helm chart model, and we have a charts directory. So let's go ahead and move into the charts directory, cd charts. And it guessed that this was a Ruby application, so it put the chart into the Ruby app. So we'll go ahead into the Ruby app, and really the only thing that we're looking at here is the basic templates and values. So if we look at our templates directory, we see that we have a deployment template, an ingress template, and a service template. So for a basic application, this is pretty much what you're going to have: a deployment that calls out the specific container, and that creates a pod and a scale engine around the pod. You might want an ingress controller enabled. In this case, for our Minikube environment, I actually did add the ingress add-on package, so we could actually turn on the ingress package. And lastly, there's a services component. And these are templates. This is a Go-based templating language. If we just wanted to look at one of those real quick, like the service template, this will build out a service manifest. Now, this is one of the things that we're effectively trying to avoid having to do as a developer. You want to focus on your application rather than on manipulating all the description for how your application has to work. And in reality, most of that has then been mapped back into the values. So if we look here in our values directory, or rather in our values file, so we did a more on values.yaml, here you see we have most of the default values that we need for these different services. So image, grab it if it doesn't already exist. Our default replica, a count of 1, so let's just create one instance. We're going to assume that our service is going to be a cluster local service. So not really useful for exposing it to the outside world, but great for using for other services to talk to this resource. That might not be appropriate, so you might want to change cluster IP to node port, or to maybe even load balancer if you're doing this in a public environment. We're actually going to do that and change this to a node port type. So instead of looking at the values, we're going to edit them. Use the VI editor, VI values.yaml. And go find the cluster, and we're going to change this to type node port. And the rest will happen automatically, so it'll select a node port for us. We could actually define a node port, but we'd have to make sure that the service is the right template relationship for that. And we're going to leave ingress as false for now. I'm not going to deal with the ingress in this particular deployment. The other thing that we might change are the resources. If we know, for example, that we need more CPU or more memory, then the default 100 milli CPUs, which is a tenth of a CPU access, and 128 megabytes of memory, if we don't think that's enough, this is a super simple app, so that's going to be plenty fine for us. But we might want to change those. And again, any additional parameterization that we want to do for our application, we can create values here and then map them to templates, config maps, etc. We can sort of continue to extend this chart, but the idea is that here we have the basics so that we can get right to work rather than trying to figure out how to get the basic application put together. Okay, if we come back out here, now the last piece of this puzzle that we have to think about is that the system needs to have a name, or the application needs to have a name. And by default, Draft picked the directory name that we started from as the name of the application. And we can see that. I'm going to go ahead and edit this file because I know we're going to have to change it. So we're going to do vi on draft.toml. So here we have a development environment. We might want to create multiple environments at some point. Our name here has an underscore in it. Now, for most applications, who cares if it has an underscore or not? But we're deploying this into Kubernetes, and names want to be DNS valid because we're using DNS for a lot of service discovery applications. Underscores are not valid in names, and so we're going to replace that underscore with a hyphen. And I did just hit R to replace the character, and then the hyphen to replace that, and then colon, right, quit. And so we're done with the configuration. Now, from this point forward, we should be actually in pretty good shape to actually build out this environment with just one more command. And in reality, if my app had been called app.rb and I didn't really want to manipulate any of the other parameters like the service component, I should potentially have just been able to say draft create draft up, which is the next command. But before I do that, there's one other thing that we're going to do, and that is we need to actually connect draft to a registry, a Docker registry. Now, again, I've already done that in my draft configuration file. I have a registry defined, which is the Docker Hub, and my user in the Docker Hub. And so, actually, what we're going to do is we're going to go look at my user in Docker Hub to see what systems exist. So we can pop here into another browser. hub.docker.com, and yeah, you can see that I've looked at the Ruby hardware app for quite a bit. So we actually have a version of this listed here. And what I'm going to do is I'm just going to go in here and say, you know what, let's go ahead and delete this repository. So if we do that, so we still have an older one, Ruby underscore HW, but no Ruby hyphen HW. So this is great. So we can see that we don't have anything here. Let's go back into the system here, clear this up. So what we're going to do now is we're actually going to run draft. And so this is as easy as saying draft up. So at this point, if all goes well and I didn't forget something else, the system is now going to first build the image. This will take a minute or two. I already have the Ruby base image, I think, downloaded, so it shouldn't take it all that long to do that part. Then it's going to have to post this to the Docker Hub, and that's going to take another couple of minutes. And then finally, it's going to use the Helm engine, its embedded Helm engine, to talk to the tiller component within my little local Minikube environment, and actually go ahead and launch the system. It's going to launch the particular image. So I'm going to have a service. I'm going to have the actual application, and I'm not going to have an ingress, even though that was one of the templates that was a part of the environment. All right, so the image has been built. Now we're pushing it up to Docker Hub, and in a second, if that actually works, what we should get. If we refresh this, we might even see it already. No, don't yet have an image pushed all the way up. Okay, something broke. That's almost always the case. So let's see what we have here. Okay, we do have a Ruby HW app. We have a tag. That's good. Just a few seconds ago, 360 meg. Not too shabby. Let's see what happened, what broke here. Okay, description, Ruby HW has no deployed releases. That means that probably I forgot to clean up the Helm chart. So the way that you clean this environment up is you can do a Helm ls, and no, I don't see one there either. But we can actually get rid of that other chart. Oh, we'll do that later. No deployed releases. Well, you know, let's just try it again. Sometimes second time's the charm. We'll see if no, we get the exact same failure. I'm pretty sure that's gonna again say, hey, no such luck here. Let's see. Let's move Ruby to Ruby minus HW. I don't think this is it, but aha. I knew there was a release there. Okay, so we're going to do Helm delete minus purge Ruby minus HW. So the reason Helm purge ruby -hw. Okay, so now it's been deleted. Silly thing. Okay, so we're effectively going to try this again. So normally what we're going to do is we're going to do draft up now. And what's going to happen is the system is first going to build the Docker image. Now it's built it before, and that's why it was so quick here. It's also going to push it to Docker Hub, and it's done that before as well, which is again the reason that the push was so quick. And lastly, it releases the application. And what that means is that it's actually used the Helm resources to push this chart into Kubernetes environment. So we can actually do a Helm ls. We can see that we actually have two applications. There's a Spinnaker application that has a failed status, but then we can see that our Ruby HW application has actually been deployed, and it's on revision 1, which is great. So the fact that it's been deployed means that we should have two things. We should be able to do, let's clear this, kube control get service, and we should see that in addition to all the other services, we have a Ruby hello world service. That's great. Node port. And all the information that we would need there. We can also check kube control get deployment. And we see we have a Ruby HW deployment here at the very bottom. And then we can also kube control get pods. You can see that in addition to some of the other pods that are running, we have our Ruby hardware pod. And one of the ways that we can actually talk to this is we can use port forwarding. So we know that we're exposing port 3000 on our pod. So if we do kube control port forward to our pod, just want the pod ID, so I'm going to just copy and paste the pod. And then we want to map port 3000. Should tell us that, okay, localhost port 3000 has been mapped to the container. So now we can pop back into our browser. First off, we might actually see a new tag. Actually, we're not going to see a new tag here because nothing has changed, which is perfect. But here we can do HTTP to localhost port 3000. And sure enough, here we get our application, and there's our little hello. If we go in here and we add a parameter, so this was looking at how the Ruby app works. We can say Bob, and what we should see is now it says hello Bob, which is perfect. This is exactly the kind of functionality that we were looking to implement within this little application, and it works. One of the things we can do though, and one of the reasons that I really like the draft tool, I'll go ahead and stop this. Let's edit our Docker file. No, sorry, let's edit our app. How about we see what happens if we sort of swap things around and paste this way around. Let's see, do we actually get a result that's any different? In other words, does ordering actually matter? Now I've changed the code, which means that I should get a new image. Now again, just to confirm here, if we go back to our hub, we only have the one tag here. I'll refresh this real quick. Yeah, and 3 minutes ago. Now, let's clear out this environment. So all we have to do now is do draft up. And you can see the build happened really quickly because there really wasn't much work to do. The push is taking longer, so I am pushing a new image upstream. That's great. And then I'm releasing the application, which means I'm telling Helm, or the Helm engine within Kubernetes, that, hey, you need to go get a new image. And if we could do a kube control get pods right now, it's only been running for 12 seconds, but it's already up and running, so that's great. Get pods. If we pop back here, we should now have a new tag in our registry, so that's great, and that was a few seconds ago. It's the one that we just pushed. And actually we can even see here the tag ID 962A. We can do kube control get pod. We'll get the data for this pod. -o YAML, so we have the YAML output. I'm going to pipe that to less just so that we can look through the output. So the pipe character in less, and where we're looking for the image. So right here at the bottom it says image Docker IO. You can see it was grabbing it from r*1 Ruby HW, and it has the new image ID. So that's actually using the new image. Now I can see if that actually changes anything. Again, we want the pod name, so we're going to copy this pod name. Clear this. Do our get pods. Grab that pod name again. We're going to do our port forward. Port forward. The pod, and then again port 3000. And it's going to point us to the local host. Hop back in here, go to our local host, port 3000. We're passing Bob, and sure enough, that works. And if we don't pass anything, we still get just the hello path. So we didn't break our application. It still acts the same way as it did before, even though we did some modification of the code. So that's good. It means that we're seeing similar behavior. And we did actually update the application. But this is really, to me, the key. Changes to your application, draft up, and you're back up and running in your Kubernetes test environment. Now, this is different than the continuous integration processes or continuous delivery or deployment processes, but it's certainly a simpler way for a developer to focus on developing their application rather than operating their Kubernetes environment to run their application, changing their Helm chart to update resources in order to get the latest version of something deployed. Draft really helps simplify that process. And this is not the only tool to do this, but I find that this is one of the simpler ways of actually implementing all of this against a Kubernetes environment.